The .NET Conf team is bringing to you a .NET Conf Focus event on January 14th, 2020 that's all about building web apps with Blazor. This will be a free, one-day live stream event that features speakers from the community and also the .NET product teams. Make sure to tune in to focus.netconf.net and come see what all of the excitement is about. Ask questions live and get some deep training on how to build beautiful, interactive, and powerful web UI with Blazor.
In this episode of the On.NET Show, we're going to learn about some of the cool features that are happening inside of Azure Service Bus. Welcome to another episode of the On.NET Show. My name is Cecil Phillip, and today we're going to be diving into one of the features in Azure that I'm a big fan of, and that is Azure Service Bus. So with me, I have Ashish, who is a program manager on the team, and you're going to tell us a little bit about Service Bus, right?
Sure.
So why don't we start off with you just introducing yourself a little bit and letting us know what role exactly do you play on the team?
Perfect. Hi. Hi, I'm Ashish Chhabria. I'm a PM for Service Bus, program manager, and I'm part of the Azure Messaging team, which includes Azure Service Bus, Azure Event Hubs, and Azure Event Grid. So we essentially take care of all the messaging properties, and I'm mainly focused on Service Bus.
Awesome.
Yeah.
So now, why don't we start off with just like a super quick introduction to what is Azure Service Bus and like what is the role that it kind of plays within that messaging space in Azure?
Right. So this is any kind of messaging broker helps you essentially decouple your sender and receiver applications, and essentially allow you to scale horizontally across your senders and receivers. But depending on your definition of a message, you can pick one of our messaging services to best fit your use case.
Sure.
So it really depends on what you think of, when you think of a message.
Sure.
Now, in our space, we essentially think of messages of two kinds. We have facts and commands.
Okay.
With commands, it's more like, hey, do this or do that. It's just when you think of a command, when you're essentially giving a directed instruction to another person or another service to go and do something. And that's where you can leverage a message broker like Service Bus.
Yeah.
So Service Bus acts as a broker that manages state transition between the sender and receiver. It works on a push and a pull model: push on the sender side, pull on the receiver side.
Okay.
It acts as a central arbiter of state, and ownership between the sender and receiver applications, and allows you to have rich control of any kind of communication features that you need.
Right.
So you can schedule messages, you can defer messages, you can lock a message on the queue, take your own sweet time to process it, and then go and complete it. If something fails, you can also go ahead and abandon it or dead letter the message,
right.
And then have an error flow based off of that. So you can leverage all of those features as well.
Gotcha.
An easy way to think of Service Bus is use it when you know all the nouns in your ecosystem. So who is sending the message, what is the message, and where is it going to?
Okay.
And when you think of all these things, Service Bus will fit your use case.
Got it. Could you give us like a really quick example?
Sure.
So let's say we use the use case of order processing as a common use case, right?
Right.
Like I have an e-commerce store or payment processing or whatever.
Right.
Like if I want to put Service Bus in that scenario, like what would my nouns be and like what would that flow kind of look like?
Yeah. So you could. E-commerce is one of our biggest customer verticals, and that's we have a ton of customers in that space. So the way it works is that let's say you walk into a website and place an order, and then there's a whole bunch of processing that's happening at the back end.
Yeah.
And this could include telling procurement to make sure, or telling the warehouse folks to essentially go and pack the order. Talk to your financial services team to essentially go and process the money that's required for the order. And all of these are directed messages to each of these teams and each of these applications. And that's exactly where Service Bus could come in and say, you could essentially trigger off a message that says, hey, this is the order that was placed, and the warehouse team knows exactly what to do with that message.
Got it.
So that's one flow. You could also have it for your operations team to make sure that the customer relationship is properly maintained. They can go ahead and send it out to a mailing company to essentially know when to pick up and when to ship the order.
Sure. Right.
So all these are very directed ones.
Right.
Right. And you'll know more when we talk about the next sort of messages, which are facts, which is more on the lines of, this is just a fact, do what you can with it, right?
Sure.
And that's how it differs from a command. A command is a more directed, message.
Yeah.
A fact is more like, hey, let's just let you know what's happening, right?
Yeah.
And then you can have a bunch of applications that can act based off of that.
Right.
Now in the facts ecosystem, we have two types. we have the time series, and we have discrete. Now, when you look at time series, right, it could be any kind of telemetry data or anything that is relying on a time series, like clickstream data when a customer comes in, clicks all over your website, and you want to essentially track their user journey. Or you have a sensor out in the field that's sending you temperature, pressure, and all the other good goodness. And you essentially want to track for any kind of major changes in the temperature, the pressure. And that's something you can leverage time series analysis for. So when you have that kind of data that you need to essentially analyze together, that's where you can leverage event hubs. Event hubs is kind of like this pseudo space wherein it behaves like a queue from the send side, but from the receive side, it acts as a database. So it's 3 times better for ingress than it is for egress. And what that means is that it can act as a sink for all of your message data coming in. But at the back end, you can read it like a log, like a tape, or you could take blobs from the back end and essentially do either a near real-time processing or any kind of business intelligence offline. So that's where Event Hubs comes into play.
So if I understand it correctly, like so as my messages are coming into Event Hubs specifically, like I can have this collection of facts that have come in, and I can decide that I want to analyze like this particular subsection of that tape, or that stored message set, and I could run analysis on it. I could do whatever the cases I want with it. But I know with Service Bus, Service Bus is more of a hey, like you said, like commands have happened, things have happened, and I'm popping individual messages off the queue or transactions of messages off the queue to work with. But then once they're gone, right?
That's So the way it works is that you maintain a cursor on your end from the client side, and you say, hey, give me this message. I'm going to take my own sweet time to process it. I could do a whole bunch of things. I can have transactions. I need to essentially trigger off more messages based off of that single workflow that I received, and then I can go ahead and complete it. And once you do that, it's taken off of the queue.
Got it. Okay. Awesome.
So it's we have at least once and at most once delivery semantics depending on how you lock the message or how you receive from the queue. But you can leverage both of these ways of processing.
Got it. That sounds pretty clear.
Yeah. Cool. So the next one is if we have discrete events or discrete facts, so to speak. It could be something like a new user signed up for your service, or someone logged in from another computer, and you need to essentially trigger off a whole bunch of security protocols to make sure that they can authenticate themselves. So these are point in time. They're not really related to an event that came in before or after them. And that's exactly where you can use Event Grid.
Oh, okay, that totally makes sense. So it's kind of like you said, like an instance in time, like an event or a trigger, or Cecil walked through the door,
basically.
Like, we sat down in this chair, And now if I want to kick off a certain workflow based on those events, but then now I'm not looking at this event like a collection of stuff, and then I'm also not sending a lot of data, right? Like I would like in a command, right? Like I would in Service Bus. Like there's not a lot of stuff in here. This is just very small, very quick notifications to be like something happened. Let's do some work with it.
Yeah. So one of the examples that I think resonates with a lot of customers is, let's say you have a smart car with like your driver profile stored, and you just walked in and you essentially clicked the button, and now you know exactly who's in the car. So all the the seat adjustments, the driver mirrors, your cooling, climate control,
things start
everything.
to happen.
Yeah. So it's like, hey, I just walked in, I pushed a button, or someone was able to scan me potentially. And all these things kind of happen based off of that. So if you didn't have a switchboard or a message broker like Event Grid in that case, you would essentially have to have all these patterns laid out individually.
Got it.
And that's exactly what Event Grid is trying to solve.
Gotcha. Okay, awesome.
Yeah. So the way we think of it is that there are multiple event publishers and event handlers, and Event Grid kind of makes the bridge.
Got it. Okay, cool. Sounds good. So let's talk about some of these different patterns that we have inside of Service Bus. Right. Because again, I think Service Bus is probably one of the oldest services that we have in Azure today. Right. So it's very mature, very robust. And built on like that cloud scale infrastructure, that we always talk about. So let's talk a little bit more about Azure Service Bus. Right. I know Service Bus is probably one of the oldest services that we've had in Azure. Probably one of the first ones, right? And it's built on that cloud scale infrastructure that we always love to talk about. And so I'm really interested to hear about some of the patterns and some of the things that we could actually do with it specifically.
So messaging as a concept is more than 50 years old at this point, and Service Bus is really trying to answer the question as to, when I move to Azure or when I'm on Azure, what can I use to as an enterprise messaging service.
Sure.
And this is our multi-cluster offering that's battle tested, enterprise ready, high availability, and geo recovery built.
Got it.
Right into the ecosystem itself.
Awesome.
Right. So from the get-go, Service Bus, in terms of what it offers, very basic, very basic semantics of point-to-point and pub-sub, with all the enterprise features kind of built on top of it.
Okay. Awesome.
So very quick understanding of what exactly do we mean by point-to-point. And the way it works is that think of a sender application or a host of sender applications or multiple sender applications and multiple receiver applications.
Yep.
Now, you don't want the receiver to block on the sender and vice versa.
Yeah.
So you want to decouple them and allow them to scale horizontally as the workload increases.
Yep.
Let's say you suddenly have a spike in the number of users, and you want to essentially leverage Service Bus to essentially decouple it and act as a buffer so that none of your customers have any kind of lag on their end.
Sure.
But at the same time, your receivers can identify the workload and take the time to scale up.
Right.
So the way it works is that the queue decouples your senders and receivers in the sense to say that the sender will send the message to the queue, and the queue will actually acknowledge the message.
Yeah.
And when Service Bus queues acknowledge the message, or even with topics, what we do is on the back end we'll triple replicate it.
Okay.
Right. And the way it works is that we will only ACK the message back to you once it's replicated in our storage.
Okay.
So once you receive the ACK, you can be sure that the data is not lost
Sure.
by
That
the
makes
queue.
sense. Got it. Okay.
Now the queue acts as a buffer for the receiver. So if the receiver is down or it's processing something else, the queue depth will keep on increasing. Right?
Okay.
When the receiver is ready to accept new messages, it can go ahead and actually connect to the queue and then retrieve the message, and then also give its ACK back to say that, hey, I completed the processing of this message, so you can remove it from the queue.
So there's acknowledgement happening on both sides.
Right, absolutely.
Awesome.
So it's a reliable system built over AMQP. So on a protocol level, we have reliability built into it.
Awesome. Okay.
And the way it works is, as I mentioned, messages are never lost as long as they are ACKed by the service. At the same time, the receiver has a control of what it wants to do once it's done with the message processing.
Got it. Okay.
So we've seen cases where obviously the message is perfect. I'm done with all the processing. I'm going to complete it and remove it from the queue.
Sure.
The message was incorrect or wrongly formatted, or maybe the sender went into a different version and the receiver has got no idea about it.
What's going on? Right.
Yeah. So the receiver's like, oops, I have no idea what to do with this message. I'm going to abandon the lock and maybe some other receiver can check it out.
Got it. That makes sense.
Or the receiver can validate the message and say, hey, this message is completely wrong. Or something went bad on the sender side, or some stage was hit that I cannot recover from. I'm going to go and dead letter the message. That puts it in a sub-entity within the queue, wherein you can go and analyze all these messages and say, hey, now I know exactly what's happening with my system.
Right.
And then have a recovery mechanism built on top of it.
Cool. Sounds good.
Yeah.
I know we have some topics. I don't want to say topics. I know we have some features known as like queues and topics.
Right.
Right. Like, could we talk about a little bit? What are the differences between queues and topics? Because
Sure.
in my head, like Service Bus is like a message broker.
Right.
And that means that it takes, it queues up messages and it passes it out to different people.
Right.
So what's the difference between like this queue concept and the topic concept?
Right. Yeah, so semantically speaking, there are two ways to think of messaging, right? You have the point-to-point, wherein one sender and one receiver. Now, it could be a group of senders, but they are similarly, they're essentially similar in their function.
Sure.
You could, like I mentioned, you can horizontally scale up your senders, but they're all doing the same function.
Got it.
On the same side, you have a whole bunch of receivers that are also doing the same function, but again, you can horizontally scale them up as well.
Yeah.
So now you have, you can have competing consumer patterns, but they're all reading from the same queue.
Yeah.
So it's exactly point to point. You're essentially mapping one function to another function. But let's say your messages are, need to reach multiple destinations, right? So it's more of a publish, subscribe.
Yeah.
It's publish, subscribe is a kind of loaded term. We kind of treat it as a multiplex and a fan out.
Okay.
To say, you know what, I'm going to have one topic that the sender only knows about, and the sender will only send to a topic.
Yeah.
And on the receiving side, we can set up subscriptions.
Okay.
And the way it works is that you set up subscriptions. You could set up a filter on these subscriptions and say,
Okay.
This subscription only cares about these messages,
Yeah.
right?
With this particular criteria.
With this particular criteria. You could say, I'm interested in all messages. You could say, I'm interested in a certain type. You could essentially filter based on any of the message header properties.
Okay.
So let's say your sender is this all-powerful being that is doing all sorts of message sends, whether in the e-commerce scenario, whether it's a new order or a bank inquiry or a success from the bank gateway, something comes in.
Yeah.
Now the sender is sending everything, but it needs to be routed to different applications and different departments.
Different things to process that message.
Exactly. So different things need to process a message. Some messages need to go to both places.
Yeah.
Right. So there are all these different use cases that you can leverage. And you can say, you know what, as a sender, I'm only going to send to that topic, but then I'm going to have filters on various subscriptions, and then these messages will get replicated over or routed to a single one.
Got it.
So what I mean by replication in this case is that if a message only satisfies one filter condition, it goes only in that subscription.
Yeah.
But if it satisfies both, it is replicated into both.
Got it.
So it's not like they're competing consumers on different subscriptions. They will have their own copy, and they can leverage their own processing mechanism to read off that subscription.
Okay, so just for me to clarify, so when we're talking about service bus queues, right, like it's a one-to-one, like a point-to-point,
right?
So I can't have multiple consumers attached to a single queue.
You can.
You
Yes.
can.
Yes, but they would all be competing with each other.
But they'd be fighting for the ability to do work.
And that's not a bad thing. It's basically it's a different model, right? When you have receivers doing the exact same thing, you can essentially have them compete against each other to process messages on the same queue. It's basically like, do you want just one receiver reading and processing it, or do you want 5? So it's scaled to 5.
I got it.
They're doing the same thing. It's just it's as if the same receiver is reading the message.
Yeah.
But now you're scaling up as well.
Okay, cool. All right, so that makes sense. So then I can have that point-to-point scenario. It's going to one queue,
right?
But then I can have multiple folks,
Really
one or more people working on that. And then with topics now I have a little bit more intelligence because routing comes into play. Right. I could do filtering. I could do broadcasts. Is what it sounds like. Like
That's
I could have this thing go across multiple people or some subset of the workers that want to process this work.
Right. That's exactly right. And so the way it works is that the sender obviously knows only about the topic. The receiver, on the other hand, knows only about the subscriptions.
Got it. Okay.
And for all intents and purposes, the subscription behaves like a queue. So the receiver, there's no difference in whether it's talking to a queue or a subscription. Okay. Can do the same locking mechanism, lock, process, complete, abandon, dead letter, all that good stuff.
Got it. Okay.
And the way it works is, as you can see in the animation, the order will be sent over to the subscription that has that filter condition satisfied, and then the code will go over there as well.
Awesome.
In the other one.
Cool. Yeah, let's move forward and take a look at a sample and see what this code looks like.
Sure. So sending to queues and topics, again, like I mentioned, these are the routing concept of topics and subscriptions is a service side detail. Yeah. From the application side, whether it's a queue or a topic, your code looks slightly different because there are different opportunities over there. Yeah. And different functionality for queues and topics. But the API gestures are comparable. Got it. So in the first case, we instantiate the queue client. You could either do the queue client if you're sending to a queue, or you can use the topic client when you're sending to a topic. Got it. And from that point forward, the code is identical. You would send as is. You just create a message. We just put a random GUID on the message ID, and just send it out there. Yeah. And we have asynchronous methods. That's exactly what we recommend because we don't want your sender application
to be blocking your process.
Right.
I got it.
And the idea is that you can get a callback on like any asynchronous method. We do have the throughput and latency are two different concepts. So you can have high throughput, and since your application will not block, latency is something you need not worry about, basically. But we still have latency under 100 milliseconds.
Okay, cool. That's awesome. And so as we're looking at the sample here, whenever we're creating messages, like the sample right here just shows like content type and message ID. Right. But I'm guessing I could set a lot of different options like the actual payload for the message, custom properties, headers, tons of different things. Right, because I think that comes into play when we talk about routing now, right?
Absolutely.
Like we could add these different pieces of metadata to the message as we send it.
Yeah, so we do have user properties, we have system properties, and I try to keep this as simple as possible.
Sure.
Yeah, we do have those available as well. The data payloads are binary,
Mm-hmm.
so we cannot have a filtering on the data payloads. It's only on the header,
Yeah.
which is pretty standard in the messaging space.
Got it.
And then we have these SDKs that can help you serialize and deserialize when you pull it back off.
Gotcha. Cool.
Yeah.
Awesome. So let's move forward and talk
Mhm.
a little bit about. I think they have the next section. We're going to talk about the tiers.
Right. Yeah. So we offer Service Bus in two tiers. We
Mhm.
have the standard tier and the premium tier.
Okay.
And we initially started with the standard tier. It was a multi-tenant pay-as-you-go model with message size up to 256 KB.
Yeah.
And the idea was that most customers needed dedicated resources
Mhm.
that could give you predictable throughput, latency,
Yeah.
bigger message sizes,
Sure.
and all the enterprise features that are required. For
Yeah.
high availability, disaster recovery, virtual network service endpoints, having managed service identity, all the other good stuff that makes it enterprise ready.
Right.
So that's why we kind of made this offering available a little over 3 years back
Yeah.
with premium tier. And that gives you, exclusive resources. You can allocate in terms of message units.
Mm-hmm.
So you could provision a service bus namespace in premium.
Yep.
You could provide it with 1, 2, 4, or 8 message units.
Oh, okay.
And the
Cool.
rough estimation is 1 MU is equal to 1 VM.
Yeah.
So that gives you sufficient sandbox dedicated resources that
Nice.
are just yours.
Awesome.
And you can leverage it. And you can also scale up and scale down depending on
Whatever your need happens to be.
Yeah.
So it kind of sounds like depending on what my size of my company is and depending on what we're doing,
Right.
like we could probably start off with standard
Right.
and do dev test scenarios. Or if
Mhm.
we're doing small workloads, maybe
Right.
I have a medium-sized company and we're not
Mhm.
putting out like thousands and millions of messages.
Mhm.
But then when I do get to that higher scale,
Right.
now I can have things like like the geo recovery and
Mhm.
bigger message sizes and those types of things for my production workloads.
That's
If I go to premium.
That's exactly right. So that's exactly what our recommendation is. If you have dev, test, and low throughput environments, use standard. Once you get to that scale, you can start using premium. If you have bigger message payload requirements, like
Yeah.
you mentioned, any kind of enterprise features. And in the past, we do not have a way to essentially migrate
Yeah.
your existing standard namespace to premium, but we've made that change. So now,
Oh, yeah?
if you start with standard and your applications are like coded against that connection string,
Yeah.
there's a simple one-touch solution to essentially migrate
To go
your
up.
standard to premium.
Okay.
Yeah.
Awesome. That's great.
Yeah.
Cool.
One thing I want to add about premium is since it's dedicated resources, I
Yeah.
touched upon this earlier, when you can scale up or scale down depending on your use case.
Mm.
We bill hourly on both our tiers.
Mhm.
So let's say you have a certain spike in your in your workload,
Yeah.
and you want to essentially make sure they're processed quickly.
Mm.
You can keep an eye out for CPU and memory usage
Usage.
metrics.
Yeah.
Depending on that, you could essentially scale up to 2 MUs.
Yeah.
Once your workload goes back to normal,
Mm.
which again you can track using the CPU and memory usage metrics,
Got it.
you can scale back down to 1 MU.
Cool.
So you only pay the premium for the slight
For that
increase.
period of time, and then
That's
you can
right.
scale back down.
Yeah.
Cool. So that gives you a little bit more control over like how you use the service.
That's exactly right.
Awesome. This is really cool. So do we have anything else really quickly before we wrap up that we want to talk about Azure Service Bus?
Sure. So I also want to talk about what our target scenarios look like. When
Yeah.
we spoke of the use cases, but
Mhm.
what scenarios are we targeting as a team?
Mhm.
And the way we think of it is, you have 2 cases, right? You have the lift, shift, and modernize,
Yeah.
wherein you have existing on-prem solutions, and we want to bring you in a controlled fashion to Azure.
Yeah.
And the goals here are to make your migration as simple as possible,
Mhm.
and also at the same time empower you to pick PaaS modules along the way. So any kind of PaaS offerings that we offer
Mhm.
that work better for your use case than your on-prem solutions, that's something we want to empower you to do that.
Sure.
And how do we do that? We essentially have the familiar semantics that you've been using in your prior queuing service.
Yeah.
These are enterprise features and secure by design. We have well-documented SDKs, and we're also expanding support to other well-established messaging APIs like JMS.
Like JMS.
Yeah.
Okay, that's awesome. So that means that if I had an on-premises solution that
Right.
uses something like ActiveMQ or
Mhm.
some other AMQP 1.0 version
Right.
supported server,
Mhm.
that I could use, I could shift from that to Azure Service Bus
That's basically
because we
right.
support the same protocol.
Mhm.
The only difference is like instead of me hosting it, Azure's going to host it, and we're inside of the cloud.
That's exactly right. And it's not just about the protocol; it's also about what API services you're using.
Sure.
Our goal is to make sure that when you move from on-prem to Azure, you do that with limited code changes and
Yeah.
potentially config only.
Cool.
So that's the path we are going towards.
Got it.
Yeah.
Okay, cool.
And the second target scenario is, if you're thinking of any kind of modern cloud-native solutions, now that is something you're building on the cloud, for the cloud, and I don't know, with the cloud. But with the cloud,
everything all leads to the cloud, right?
Yeah, but the way it works is there, obviously messaging as a concept is very old, but we want to modernize it. And the way we do that is we play well with other Azure PaaS offerings.
Yeah.
So Azure Logic Apps, Azure Functions, Azure Event Grid is homegrown. It's part of the same team.
Sure.
But essentially, you can play well with hey, if there's an event, I want to decouple my receiver application. I want to send it to a queue, or I want to trigger off this Azure function or Logic App. I want to send an email when a message is dropped on my queue. All of those good things can be built from within Azure itself, and that will really simplify your programming model as you build these cloud-native solutions. Yeah,
I think integration between different services is a huge benefit when it talks to about moving to the cloud and picking what are going to be the components that I'm going to use.
That's right.
What I mean? It makes my job as a developer easier, and also from a business perspective, it just makes things a lot less complicated.
Totally, yeah. And that's the goal with these two target scenarios that we have.
Cool, that's awesome, man. I'm looking forward to talking to you some more about Azure Service Bus. We're going to have to do some more videos and continue this conversation.
Absolutely.
But thank you so much for coming on. I really appreciate it. And thank you all for watching. This has been another episode of the On.NET Show, and we learned just a little bit about Azure Service Bus.